Here, before we start talking about like real life things, we are just gonna graph some things and make sure that we kind of understand like what's happening here. So here we have this linear function and we want to find its inverse graph. And so visually, I think it helps. So we're going to start with visual things. And so we have here, this first point is -1, -5. I'm going to write these off to the side just so it's easier. We have 0, -1. We have 1, 3. And we have 2, 7. So those are our 4 coordinates. And so what we're going to do to find the inverse, sum of the coordinates of the inverse function, we would switch the x and the y value. So this would become 7, 2. It would become 3, 1. It would become -1, 0. And -5, -1. So nothing changes about those coordinates. Nothing changes about the numbers. They just switch location. So here I have 7, 2. So I have a coordinate there. I have a coordinate at 3, 1. I have a coordinate at -1, 0. And I have a coordinate at -5, -1. And so then if we take our line and graph it through those points, we have the inverse function. So I'll graph this. But if you notice, we have symmetry about the line y equals x. And so I'll make that a different color just for ease of life. And so we're reflecting this point over here, the second point over here, this point over here, and this point gets reflected over here. And so everything gets reflected over that line when we switch the x and y values. All right, moving right along. So here, I want you to take this exponential graph, or this piece of this exponential graph, and I want you to sketch it in your notebook and see if you can come up with its inverse function. So what would the picture of this inverse graph look like? So pause the video, draw your graph, and see if you can come up with this one. So we have -2, 1/4. 1/4. Sorry, my handwriting is not great. We have -1, 1/2. We have 1, 2. And we have 2, 4. So when we switch those, we end up with, let's use a different color. We have 1/4. -2. We have 1/2. -1. We have 2, 1. And we have 4, 2. So here I'll start with 4, 2. Here we have 2, 1. Here we have 1/2, -1. And we have 1/4, -2. So here I'm going to graph this as best I can. And so you should be able to see that this line, and hopefully this matches your own graph, our line of symmetry here, this curve is reflecting over to this side. And so that's kind of graphically what's happening here. On this last one, I want you to take a second and think about what happens when we reflect over y equals x here. So I'm going to draw this line in, and we're going to reflect it. So reflect it on your paper and think about what happens here. Think about all the possibilities. So here, this point is going to reflect over here. We have a couple of points, and we're going to reflect each of those. And so 0, 2 becomes 2, 0. 2, 3 is going to become 3, 2. And 4, 2 is going to become 2, 4. And 6, negative 1 is going to become negative 1, 6. Right, and so then when we connect these, it'll look something like this. And so the problem with this is that this function is not one-to-one. The original function here, this red graph, is not one-to-one. The y values here and here repeat. And so that's causing a problem for us when we reflect it over the line y equals x. Now this is not a function because these y values are repeating here with these y values. And so there's some stipulations that we have to put in when we're talking about these types of functions when they're not one-to-one. We have to make them one-to-one. And so here we have 0 to 2, or we could keep 2 to 6. Because this piece or this piece, okay, those are invertible. They are one-to-one. So if we kept this piece from 0 to 2, then this would be my inverse function here. If I kept 2 to 6, then this would be the part of my inverse function that I'm going to keep. So on today's assignment, you guys are going to have to restrict some domains that match what's happening in my equation. So just like we talked about square root functions back earlier, we're going to continue talking about them here along with our domains.